Okay, so first of all, it's Shafreen Anfar. It's not that's fine. So this is the last session of this track. So I'll make it as long as possible. Just kidding. I'll actually do the opposite. I'll make it as short as possible while giving the message of WebSub. Okay, so as I said earlier, so we are going to talk about WebSub as an enabler to facilitating integration. My name is Shafreen Anfar. I'm an architect slash associate director at WSO2. I've been working for WSO2 for almost like 11 years and counting. Additionally, I'm an Apache committer and a PMC member. So you can find me on Twitter as well. Along with me, Ayesh Almeida will be co-presenting this presentation. He's an associate technical lead at WSO2, and you can find him on Twitter as well. Okay, so this is the structure of the presentation we are going to do today. We'll start with the problem, and then we'll discuss a bit about the solution, which is WebSub, and then we'll discuss a bit about the benefits of Ballerina WebSub. So that's the structure. Okay, so to start the presentation, I'll say this. So Ballerina and MOSIP connection and the problem that brought us together. So I'll start with that. So to start the presentation, I thought of using this image. This image is taken at WSO2 office in Sri Lanka, and these are my teammates from Ballerina team. Here you can see they are working on a puzzle. So this puzzle had like 1,000 pieces. So imagine like figuring out the right piece and putting it to the right place and how hard it is. But the thing is, the end result is quite rewarding. By the way, at the end of the presentation, I'll show you guys the completed puzzle. So now you guys have some reason to stay till the end of the presentation. Just kidding. Okay, so while we were working on our puzzle, MOSIP team was putting together a large puzzle in the form of a distributed system. Of course, this puzzle is much complex than what we've been working on. So they just came to us and said, guys, we need a way to integrate external users to our system over the internet. So integration is something we've been doing as a company for 20 years. So we straight away felt like we should collaborate with MOSIP to solve this problem. So this presentation is about a piece of that larger puzzle. The piece Ballerina team helped MOSIP to put together. Okay, there's a fun fact about this story, by the way. Even though we've been working for like maybe 2 or 3 years, for 2 or 3 years, both teams haven't met each other in person until now. Until we did 3 million requests per day. Yeah, it's a crazy story, just to say the least. Okay, so going back to the problem. So what is the problem we have? The problem we have is a distributed systems problem. So then the question is, what is a distributed system? So at a very high level, we can say a distributed system is a collection of servers or systems working together to do something meaningful. Of course, there can be many other descriptions, but let's just stick to this one for this presentation. Okay, so then if a distributed system is a collection of servers, how can we organize them to do something useful? There are two main ways. One, you can use the request response architecture. The other one is you can use event driven architecture. we call it EDA as well. So here, if you look at the request response architecture, in this image you can see we have system 1 and system 2. And if system 1 wants to communicate with system 2, system 1 can send a request to system 2, and system 2 can do something meaningful and send back the response. So this type of communication we call blocking or synchronous communication. So if you look at the other one, which is event-driven architecture, now you can see we have a message broker in the middle. So what is a message broker? Again, at a very high level, message broker is a queue or a topic. So there are many different implementation of message brokers like Kafka, Nets, RabbitMQ, and so forth. So say system 1 wants to communicate with system 3. So in this case, what happens is that system 1 just sends a message to the message broker, and then via the message broker, system 3 can consume the message and do something meaningful. So in this context, we say system 1 is the producer and system 3 is the consumer. So this type of architecture has its benefits. For instance, it is easy to add new systems to the existing one. You can easily scale the existing system. And these types of systems are reactive and responsive, as in as soon as you send the message, you can get a real-time response. Of course, along with these benefits, there are like challenges as well. For instance, in event-driven architecture, when it comes to debugging and tracing, it could be a bit challenging. But of course, in this case, benefits outweigh the challenges. But there is a slight problem when it comes to EDA. They like to operate in a confined or controlled environment. So, for instance, these environments are usually managed by a given organization. Say that organization decided to use Kafka. In that case, the communication between producers and consumers depends on Kafka protocol, and that protocol becomes a local technology for that organization. But the problem is, MOSIP wanted to go beyond. They didn't want to get confined into a controlled environment. They just wanted to extend their system over the internet. So the problem is, message brokers like Kafka, RabbitMQ, or whatever feels like a foreign technology when you go out there to the internet. For instance, when I'm here in this hall, boundaries are well defined. Everyone here understands English. If not, there are translators. Therefore, I don't feel like a foreigner. But as soon as I step out into the city, this city is evolved around Ethiopian culture, and they speak Amharic. So I straight away feel like a foreigner. So same story applies here as well. I'll tell you why. So if you look at the internet or World Wide Web, which has been there for like decades, if you look at the building blocks of internet, you can see three main things. You can see URL, HTTP, and hyperlinks. So everyone in the internet understands HTTP and URL. Of course, they understand hyperlinks as well, but we are not interested in it for this session. So internet has been evolving around these technologies. So now the question is, how do you extend your EDA over the internet? I guess the better question would be, what is the best way to extend your EDA over the internet? The solution is WebSub. So before I talk about WebSub, I just want to introduce this word to you guys, which is WebSub Hub. So if you guys can repeat that word for 5 times without making any mistakes, you get free dinner on us. Just kidding. So that's the previous name of WebSub, and I'm glad that they came up with a better name. So if you look at WebSub, it's an open protocol for distributed PubSub communication. And it is based on HTTP. That is the key point. And if you look at the main roles of WebSub, like in any event-driven architecture, you would see a publisher, subscriber, and a hub. So the hub is the one we are going to talk in detail. But for now, let's just move on. Here you can see, like, if you're interested in the specification, you can go to this link and read about it. The key point you need to remember is WebSub is a PubSub. So I just told you guys we're going to talk a bit about the hub. So the hub is implemented using Ballerina, which is a cloud-native programming language. So I'll give a quick introduction to Ballerina as well before we talk about the hub. So Ballerina is a programming language, and it's an open source programming language. Therefore, if you're interested in the design and development, definitely you guys can get involved as well. So it is developed by WSO2 since 2016, and the first released in February 2022. It has a rich ecosystem of network protocols like WebSocket, gRPC, HTTP, GraphQL, so on and so forth. And it has support for different data formats like XML, JSON, protobuf even. And then when it comes to connectors, it has wide array of connectors that you can use to connect to different systems. It has a textual and graphical way of editing stuff, built-in concurrency stuff to make sure your services run without any issue. So I don't want to go into details, but in summary, just keep in mind that if you have a team of developers and if you have an integration problem, Ballerina is something you should definitely consider. Okay, so let's talk a bit about the Ballerina WebSub Hub. So this is the hub MOSIP used in their environment to integrate external systems into their system. So to talk about the hub, I'll just invite Ayesh Almeida because he's the lead developer of Ballerina WebSub Hub. Ayesh, over to you.
Thanks, Shafreen. So as Shafreen mentioned, I've been the lead developer in the system, and I've been working at WSO2 for more than 3 years now as an associate technical lead. So let's dive in. So this is the high-level architecture of the system. So you can see there are several key components in the system. So first, we have the WebSub Hub itself. It's a standard implementation of a WebSub compliant hub, and it provides an HTTP API which you can use to manage topics and subscriptions. And almost all the software systems need a state, and to manage that state in the system, we have a component called consolidator. So as Shafreen mentioned, this system is event-driven. This system adheres to event-driven architecture. So in event-driven architecture, there's a popular pattern called event sourcing, where instead of storing the entire state as a whole entity, you will be storing the sequence of events which describes the changes to the state. So we are using that here. So consolidator is the main component who's managing the state of the system. Then we have Kafka message broker. So this doesn't necessarily need to be the Kafka message broker. It can be any message broker. So we have used Kafka here because it's quite popular and it's quite easy to use message broker. So Kafka we are using here as a persistent storage. So like we'll be storing the state related events as well as the messages related events in the Kafka message broker. Then we have producers. Producers are simply HTTP clients who are connecting to the hub to publish new messages or updates. And it can be written in any language or framework. But in Ballerina, we already have a tailor-made publisher client, which can be used to seamlessly integrate into the WebSub Hub system. So if you are using Ballerina, you are in good hands. So then we have the subscribers. Subscribers in the WebSub scenario are basically HTTP webhooks. So it can be also implemented using any language or framework, but Ballerina already has provided the ready-made WebSub compliant subscriber implementation as well. So those are the high-level components in the system. So let's talk a bit about the quality of services functionalities which is provided by the hub. So first, we have security. So in this system, there are 3 main communication routes. First one is from publisher to hub. Then we have communication from subscriber to the hub in the initial subscription process. And after that, we have the communication from hub to the subscribers when delivering messages. So all of these communications are secured via SSL or TLS. So we can basically call it over HTTPS. Then to manage the authorization and authentication of aspects when connecting to the hub, we are using an external IDP. So as the authorization protocol, we are using OAuth2 with a JWT. So as you can see, now we have there were 3 main routes of communication. We have secured 2 of the main routes, which are like how where publishers connected to the hub and also subscribers connected to the hub. So how the subscriber is going to authenticate when a content is published to the hub and hub tries to deliver that content to the subscriber. In the WebSub specification itself, it has a standard way of doing this. So when subscribing to the hub, the subscriber can provide a secret, which is a textual value. So when delivering the content, hub can generate a hash using that secret key and the content and set it as a HTTP header, so which in turn subscriber can read and validate against the content it received. So that way there's a security mechanism in between the communication from hub to the subscriber as well. So let's talk about scalability. So in our system, most of the workload is happens because of the content distribution process from hub to the subscribers. So that is because whenever we are getting a new subscriber, we have to create a new Kafka consumer, and the Kafka consumer will be listening to the messages coming into the topic, and once there's a message, the hub has to send that message over an HTTP request. So in a nutshell, we can say our system's workload increases whenever the number of subscribers increases. So in a way, we can upgrade the resources. We can add more resources and scale up and let the hub handles more subscribers or workload. But rather than doing that, we can also run multiple hub instances and distribute these workloads among those hub instances. So what I can say is like about the scalability, the hub can scale up as well as scale out. So what does this mean? So if you have 1,000 users, we can support that. If you have 100,000 users, we can support that too. If you have 1 million users, we can support that as well. So the hub has the ability to scale at any way you like. Then talking about the resiliency, in a software system, there are 2 main aspects you have to consider when we are talking about resiliency. First one is how that software system behaves when there's an internal issue. And the second one is how that system behaves when there's an issue while connecting to an external system. So let's talk about the internal issues. Let's say mostly there can be unexpected system breakdowns or unexpected system shutdowns. In our hub can reinitialize, whenever we restart the hub, it can swiftly reinitialize the state and start on doing what it has been doing, because the consolidator has already published the latest snapshot of the state. So that's about the internal issues. Then let's talk about how we are going to handle the external connection issues. So the main and the prominent communication, external communication happen in this system is from hub to the subscribers when delivering content. So there can be 2 scenarios. First one is there can be transient failures where the subscriber can recover. So in that case, Hub will try to redeliver the content for a pre-configured amount of retries. So the subscriber will receive the message. Let's say there's a non-transient failure. Like imagine the printing shop who's printing this Aadhaar ID card has an internal issue and that service is not working. So in that case, Hub will check whether he can deliver the content. If he can't deliver the content, he will mark this subscription as a stale subscription temporarily. And once that service comes online, Hub will redeliver the content from the failure point. So there won't be any message losses as well. So that's how the system handles the resiliency aspect of this particular WebSub Hub system. So that's all about the architecture and all. Over to you, Shafreen.
End of the presentation, and as I promised, this is the completed puzzle. As you can see, it's a beautiful puzzle. Similarly, what MOSIP has put together is a perfectly completed puzzle, and we are happy to be a piece of it. And I think it's now your turn to benefit from what MOSIP has come up with. Okay, so that's all we have. So if we have any questions, we would like to take them now.
Question, can you tell us how WebSub contributed with MOSIP? Like in which areas specifically, or if you have an idea? How do you utilize your WebSub?
Yeah, like so. So the main usage of WebSub is to integrate external system into their existing system. For instance, like one example user could be the printing shop. If you want to print an ID, you will be integrating the printing shop to the MOSIP system using WebSub. So that's one use case. I guess there are many other use cases. The key point is like whenever you integrate external systems to WebSub, you would be to MOSIP, I should say, you would be using WebSub. That's another question. Can you guys pass the mic?
Hi, I'm Puru from OpenCRVS, and is this written in Java, or is it structured as a project itself?
So this is written using Ballerina, which is a programming language.
Oh yeah, it's a
developed
program
by
in
WSO2.
itself. It would be cool to see some kind of example how it actually the code looks and how it works.
As in the code itself?
Yeah.
I see. So we can share the link. So all the code is in GitHub and it is open source. It's out there in public. So we share the link and you can go through the code.
Cool. And so as looking at this as a civil registration perspective, would we be deploying this as a part of our stack, as a OpenCRVS stack, if we were to integrate with MOSIP, for example?
So the question is, if you want to integrate with MOSIP, do you want to deploy this component or WebSub server?
Yeah, as currently we are using just webhooks, JSON webhooks, and I'm kind of struggling to understand that what kind of structural changes would we need to actually deploy this or use this in our system.
Okay, so if you want to integrate with MOSIP, say, in that case you don't have to do anything, you just need to use the subscriber, which is a webhook again. So WebSub, what WebSub does is standardize how you use webhooks. That is what it does. Along with that, they have come up with a set of rules as in how you should write a hub when it comes to adding webhooks. So those things are the things we have done as Ballerina WebSub Hub, as in implementing the WebSub Hub, which is a server. So if you deploy that server in your system, other parties can consume messages of your system using webhooks. The way you produce messages can be in any form, but when it comes to consuming messages, they also now can use webhooks, like you use webhooks to connect to MOSIP system.
Okay, yeah, it kind of answers my question, but I really need to see the documentation to understand it a little bit better. Thank you.
Okay.
So, okay. Hello, everyone. My name is Khaled. I'm an ID architect. I had this opportunity to work with MOSIP from really early beginning in the journey. So I'm really aware and also fan of all the steps has been taken by MOSIP and the implementations and all the let's say where MOSIP arrived at the moment, and what I was responsible actually for, which I'm also proud of being part of this journey, is the implementation of in 2 countries, which is Morocco. So it was the first challenge for me with MOSIP, and also in Togo, which is both of them are in production. Morocco now is like enrolling and authenticating, social programs are working. So the system is like is one of the backbones now in Morocco as for social let's say for social aid, for social programs, etc. So enrollment and authentication is actually working. Talking about Togo also, they are working towards this very soon, rollout, etc. So I'm not really allowed to talk about all the details, but this is one of 2 projects that I was responsible. I'm still responsible for. So we put it from 0 to production. Helped, of course, the country, and we work together, work very very closely to achieve this milestone. So these are like the same the two projects. I will just start with the presentation to continue until they finish. So just to give you an idea, working with MOSIP is a challenge and also fun. So, and the way they put it is really amazing. I'm trying in my presentation to put things really in a very high level. Talking about the integration points that is actually in MOSIP in different components. I was not able to put all the components, but I put the major components that are there. So we will be talking about the integration points and what MOSIP are helping in their system by default, enabling things to us, and how we can use it. We used it actually in integration. What are the points that we need to take care of during the integration, etc. And also, it's a journey. It's a journey starting with the requirement from the government, putting a specification, going for customization. We will not be talking about customization today, just very straightforward, the integration points and the benefit of having MOSIP as an ID system, okay? So let's start. So here we talk about ID system integration and interoperability with MOSIP. So this is the introduction. I was introducing myself, also what is the project achieved. So now we're talking about the integration with MOSIP. What is the interoperability with MOSIP, journey and challenges that we had during this integration phase. So talking about the challenges. So what are the common challenges that we usually have during integration of systems? So as system integrator, we are keen on having several points and challenges that we always tackle, okay? So first one is the data security. So if we are talking about very sensible data like biometrics, demographic data, and all this stuff, it must be secured. So this is one of the biggest issues when we are talking about sensitive data, especially when we are talking about country size and country related programs. Sorry. So, and also here we have varying standards, which means in our world, when we have a system, we need it to work. So the system will not work alone. So it needs to work with other systems. So there's so many standards out there. So what is the best standards to take, or how to integrate it with our system? This is another challenge also. So especially in big systems. So also there is a cost of implementation, which means, okay, if I have a system that actually not enabling me to fast integration, I will be paying a lot in terms of money, in terms of time, resources, everything. So this would be so costly. And also here, as I said, it's a time for adaptation. So the system must be so flexible to be able to adapt it fast to my need, because the need of one country is not the same as other countries. So this is also one of the challenges, the common challenge that systems can have. So also the data sharing. Data sharing means, so okay, I'm working with a very big system. I need to give some information to people. So some entity, some programs, some system. It's an external system or internal system. So if I will do this, I need a way to share data. So which means that if I did not share the data safely and securely, and also in a very fast and correct way, this will be a big challenge. So if I need to figure out how to do it with each system, which is today it's not possible to do it, because there's also standards to do this, which MOSIP is adapting. And it's one of the things that we will talk about. So these are just the common challenges. There's so many so many challenges we can talk about, but these are the most common ones. So, okay. Here, let's say integration is like a game, so we can put it as a pieces. So how to put all the pieces together. So, and how the system will help us to put these pieces together. So this is a little bit interesting, because it's more or less like a game for integrator. That's some people are like really find pleasure in doing this. So this is one thing. So let's take it from this side. Okay, talking about MOSIP. So let me tell you about MOSIP. Is a core system in ID. So it's a core application. However, this core application is put inside a huge system, which is you have your infrastructure, you have your orchestrator for microservices, you have your network components, you have your security systems, everything. So this is the core system that gives you the core functionality, but it's part of a bigger system. So which must be done for any ID for government. So you need to protect your system, put it correctly also from outside. So this is another story. Now we are focusing only on the application itself. So this is the application. How I see it is, or let's say how I put it here, that we have kernel MOSIP and other component of MOSIP around, which either given by MOSIP or can be added on top of MOSIP to work seamlessly with the ability to integrate seamlessly with MOSIP also. Okay, so let's put it like this. We have the kernel. This is MOSIP here, and we have different modules. This is not all the modules, to be honest. So there is lots and lots, and we can add more and more to come. So we can start by the kernel. So the kernel part. Here we talk about the common challenges. Now we talk about how MOSIP, or the enablement that I like used or helped me a lot in integration with MOSIP. What is it? It's the APIs and messaging system that actually MOSIP are putting and using. So in MOSIP you can find plenty of APIs everywhere. So you can use it. So it's already there. It can be used, and it's also secured. So they have a secure measure that you can use. So this is a very important thing. Second thing, we were talking about the data share. Data share is very important. It's a core component in MOSIP, and how the data is shared. So there is a component for configuring. You can use it as a configuration to share data with entities or even internally with the system. So this is also something very important. And it's not only to share, it's how to share in what structure, and also secured, which means that with one partner, you can share data that it's not accessible by other partner, it's not accessible by anyone. There's so many layers of encryption and also authentication before you can go and grab the information from there. So this is a component in MOSIP. So this is really enabling us to do so many things. We talk about the secure data. So secure data is, like I said, there's plenty of levels of security. So in MOSIP, there is a zero knowledge security, zero knowledge for, let's say, aspect. So there is no way the information is not is anywhere, that whenever it's stored, it's encrypted. Just you pick it, you use it, and that's it. It's only memory. And also MOSIP is giving us standards. So in parts that there is an ecosystem, like for example, devices. So there is an SBI, for example, so they put standards for this. So if you want to use and be part of our system, here's the standards. You just need to comply, and this makes life easy to us. Okay, there's also the design itself. The design itself is microservices. Microservice design is actually helping for scalability. So you can scale your system, of course, if you have enough infrastructure, etc., but you can scale your system as you go, or there is a problem, maybe let's think of, we have so many authentication happening right now and our system is not responding, so you can just scale. So this is a microservice. So the architecture of MOSIP is microservices, which help us to do this really fast. You just scale up and you are okay. Also, one of the great things is the code source, which is an open source, which means that you can go anytime to the code source, develop something, customize, whatsoever. If you have something to add, this is also enabled because you can develop. You can actually develop, deploy, and have your customization there. So this is another point, very important one. So okay, this is the kernel. The kernel is not only like this, but it's just what is the kernel commonly enabled also. So one of the parts is the enrollment kit, which is the registration client. So enrollment kit is very simple. I will put it very simple like this. So we have, imagine this as your PC, okay? So this is the PC of enrollment, and the kit around it. You have the rig client here, which is MOSIP rig client. You have the devices, depends on what you will be capturing. So we have by default face, iris, and fingerprints. And also you have here, as I said, there's standards that MOSIP has put together for SBI. So the device provider should have the SBI here with the standard of MOSIP. So in this case, it will be integrated seamlessly with SBI. So this is an interface defined. Here and in this part, you have your biometric SDK. So your biometric SDK is something vital that you need to integrate to make sure that you are capturing the right biometrics and you have the right quality, all these stuff, and these are also controlled. So I will not be able to go really down on this, but because it's lots of details, but just to give you a flavor on how things is done from a little bit high level. So here we have the SBI. So let's say we have this biometric fingerprint. So it has its own SBI that is actually using or integrated with the BioSDK. So you would choose your provider for SDK, so it could be anyone. You integrate with it for, let's say, quality check, etc., etc. So anyway, this is one of the point of integration. And also we have a very important component here, which we call the management server. Management server is very crucial that you need to use for key rotation, certification. So this is a journey here to be able to validate the trust of these devices, which means you need to trust whatever device you are using during enrollment, so no one will be able to use an external device without being authorized. So authorization is really important. That is managed by certificate and management server here. So it's a life cycle. Management server, of course, is not in the kit itself. It's in the back end. However, it's important to put it here to mention it. So this is more or less how the registration kit looks like. From a little bit down, it's not like what we see in the kit. You see only devices, but this is a little bit how it goes. Okay, going to the next step, which is the registration process. Registration process is a core part of MOSIP. I have put some of the things that we can integrate here, which is, let's say, let's say this is the registration processor. We have the packet coming. Packet has all the information that we need, biometrics, demographic, etc., etc., etc. So now we need to integrate this backend or this registration process with different components. So, for example, a very, very simple one is integrating with the SMS and email service. So we have SMTP protocol that we can integrate. We can use or integrate an API for an SMS provider just to do this. So this is very easy to be done with MOSIP. So actually, going for another interface that is actually also provided by MOSIP, which is the messaging. So we have, for example, an active MQ that we can use to send messages across the system, and consumer can use it. And this is also a standard used by MOSIP here. We have a very, very interesting and very important component, which is the HSM. So the HSM is here integrated with the backend, with the registration process of MOSIP and the kernel part of MOSIP. This is the component that is responsible for the storing the key, the encryption key, the certificates, etc., etc. So this is a very, very important one, and MOSIP is adopting the PKCS 11 interface or standard to be able to seamlessly choose your HSM provider and integrate with it. So this is another integration point. We have a very important also integration point, which is the BioSDK. So we talk about the BioSDK and the registration client, and also we have the BioSDK at the backend, which must be integrated because there's so many services here during the registration process that needs to be, let's say, use this BioSDK for quality check, for authentication, for many things. And also we have an authentication services that needs the BioSDK to be integrated with, so it can work and with biometrics. So this is another also point of integration. Okay, so here we have the object store. Object store is where you put all your packet information, whatever you get from the field, so you store it there, and other stuff in this object store. And object store standard by MOSIP, they are using S3 interface. So, and of course you can choose your, let's say, whatever object store is compliant with the S3 to integrate it. The last one here is the custom stages. So the registration process is a microservice-based architecture, which has different stages and several stages. These several stages you can add your own stage. So imagine you have an external system that you need to talk to. So if you want to talk to this external system, you can put your own stage and you put all your code there that you need to do, and you contact or you talk with this external system as a one step in the registration process. Let's say verifying, consuming, whatsoever you can do with this custom stage, and MOSIP architecture allowing this. You need, of course, to code this, to put it, to make it work, but it's an architecture that's actually allowed this, which is very nice, and also we already implemented this in different places. So this is how the registration process more or less look like from very high level, specifying a little bit the integration points here. There are lots of microservices and also other integration points, but we will not be able to cover everything in this. Okay, so going to a very light integration interface with MOSIP is the pre-registration. I think this is where the citizen is doing his pre-registration before he's going to the center to be enrolled. So here also we have an integration point. Let's say this is to the left side is the pre-registration where the citizen is trying to do his pre-registration. Here we have an integration point, which is APIs with the back end of MOSIP. So there are services for pre-registration that you can use and build your UI around it. MOSIP is actually giving a reference implementation of the pre-registration, which is pretty robust and can be used. And also there is a standard here. So they have MOSIP has also standards on how you build or you put the schema, because there is a schema validation thing that is happening. So everything must be coherent, means the data that you will put must be the same data or the same type of data that will be used, because these data can be used also during the registration process, which means this will cut short filling all the information. So here's another integration point with an API that can be that is actually used by the registration client, where they can consume all the pre-registration for a certain person. So here is a little bit how it's going. It's going in between pre-registration and the back end also, or the registration process and registration client. Okay, so the other component is very important also, ABIS. ABIS, we all know this is used for deduplication. So how is this put in MOSIP, or to be work with MOSIP? MOSIP is defined its standard, okay, on how to communicate with different ABIS, let's say providers. It's a standard through messaging bus and standard message format or structure in request and response. So here we can see that request is going, response is coming. This is ABIS. It can consume any multiple type of biometrics, do the deduplication, and then give back the results. And also here it's not only this. We already talked about how can we share the data. So sharing the data with ABIS is going through the data share itself, which means it's very important, and it's play a crucial part here on how the ABIS or whatever ABIS can access the information. So it's not giving to anyone. So it must be identified, and also the biometrics are secured during the transaction or the sharing, using the data share enablement that I talked about earlier. Okay, so we go to another component, which is the authentication. So authentication is part of MOSIP. They provide APIs for this, robust backend, and also so many layers. Let's say here, to do the authentication and the eKYC, we need to, MOSIP are actually giving us all these things, which is data encryption, because the data is always encrypted, and also it's a control, give us a control on who is accessing. I must know who is accessing, what he can access. This is something I can also configure, what he can access and how can he access it. Means that how can he can access it through an OTP or through an OTP and biometric, say iris authentication. So all these how is also configured. And also the challenge to access, which means that if I'm the citizen, I'm trying to do authentication, so it will challenge me with validating my OTP or validating my biometrics for sure. So this is on who is accessing, like the partner or the user agency, we call it, was trying to access for authentication. And then the last step is to challenge if this is the right person who's actually in front of me or not. So this is, let's say, the citizen who's trying to take the service. So let's put it from here, like we send the data here. This is the steps that's happened. We send the data after the preparation and encryption. So this is the user agency. Let's say it's a component called user agency. It's developed above MOSIP, which is also follow the architecture of MOSIP, and then we verify the source and license certificate for the partner who's trying, or the user agency is trying to do this. And after we decrypt, of course, the request when it comes to the backend using the HSM and the keys that we have already talked about. Verify the request and access level, which means, okay, now we have this, we decrypted, it's the good partner. Can he do this? Is he allowed? Is he not allowed? So if he's allowed, we go to the next step, return, verify that, of course, the challenge, the access for the citizen. If it's okay, we return the if the challenge is passed. So this is how it's done for the authentication and KYC. Okay, this is one interesting also use case, that it's the card. So some countries are actually looking for the card and to give it to the citizen, print it, and deliver it. So here we can see that printing and verifying delivery. MOSIP are also giving us the possibility to have a printing request coming from the system itself, which we can take and do whatever we like with. So the print request comes after the generation of the ID for the citizen, for example, and then the whole process can start. So you can see here, this is the integration point, with it's a print request. My friends here were talking about the WebSub and how it can give or initiate printing request. So this is done by WebSub, okay? We take it from here and we start working on it. So this is a printing solution. Actually, it's done by us, so we have put this. And this is one also of the point of integration. You can have a full component that is actually can integrate with MOSIP, do your functionality as a standalone, but it's also integrated seamlessly with MOSIP using the enablement points. So here, this is a printing solution. We will not go into details of this. However, you can see there's an APIs here, there's a printing solution or solution provider that can print the card and get the request from here, print the card. So it's validate the printing order that is coming, print and check the card, notify as card is delivered. So also the system get the notification that card is actually ready to deliver. So it's there waiting to be delivered. From the other side is delivering this to the citizen. So we cannot just go and give it to the citizen like this, okay, and then he can sign. It's not, I mean, it's a digital world, so we need some kind of proof that he actually took the card. So here we have already developed an application for delivery of the card, which is based on authentication on fingerprint. So we're using the authentication of MOSIP, we built on it, to authenticate the citizen and to mark that the card is delivered. So there is a process here. So they scan the QR code using the application. So the card is coming with a QR code. We scan it. We challenge it with the UIN or the ID given by the citizen. If all good, then we move to the next step, which is the authentication. It's a biometric authentication, which we consider kind of signature. So if it's passed, the agent will give the card to the citizen, and then it will be marked as delivered. So we know that for sure the card was handed to the citizen himself and no one else. Okay, so let's say when you finish all this, or you are in the journey of enrolling people, authenticating, etc., you will need KPIs. You will need to see. You will need the dashboards. You need things. What did we do? What do we have? So it's the BI, of course. So this is also a slide for the BI and how it's done. So always here we can see MOSIP backend and how we integrate with MOSIP backend using also API provided with MOSIP. Maybe we built APIs because we have the source code, so we can build some APIs that can help us. We have Kafka we chose Kafka as our bus, okay, and we have connectors. So all these are plugged in, and MOSIP it's possible to do this with MOSIP. We do all this stuff, and it works very, very nice. And then we have our environment for business intelligence. We have our data lake. We have our engineers, of course, here. You can see. So the data lake, everything is put there, and then we start to building the data warehouse. So data warehouse, and then we get the KPIs. So this is how it's built. Going from there, there is the identification of production data sources. So what is the data sources that I will need to consume? Is it everything, subset, etc.? We use this connector and these APIs to collect the information, okay? So it's data collection. And then we start to organize our data, put it in a data warehousing, generating the indicator, and then of course we will have the insights that everyone wants to have. Like they need every morning, the dashboards, what did we do yesterday, how many enrollment, how many, etc., etc., etc. So this is one interesting thing that is actually already done, and it can be done with MOSIP also. This is one slide. It's the last one. So this is the portal. I did not really put anything, but like a slide, just to give you what is done by a portal. Portal, we have a public portal. So usually when you have an ID program, big, so you must have a portal for the public to access services, to access information, to know where to go, how to go, what to do, etc. So it's more like instruction, but not only this, it's also services that they can consume from MOSIP backend using the APIs of MOSIP, or also developed API that respond to the needs of each country, which is also possible to be done because we can customize and integrate with MOSIP on this. So it's a resident services, we call it. In terms of name, it's resident services. For example, someone can check the status of his registration. So it's a very simple thing. So I did registration yesterday. I don't know, I still did not get my ID. So where am I? So you just can go to this portal, put his RID or the enrollment number, we call it like this, and we get the status. As simple as this. So he doesn't need to call or call the call center or do anything. So just go to the portal using the resident services. There are multiple services like downloading his, let's say, card, or maybe checking his history of authentication, unlocking his biometric authentication, because he's worried to, like, okay, I will unlock it if I will use it, I will lock it if I will not use it. So many things, like, and these are actually already there, and it's enabled by resident services, and more, of course. There is no limit for resident services that you can give. So that would be it. I hope I did not take much of your time, really. And if you have any questions, I'm open.
Hey Khalid, nice presentation.
Thanks.
I think the presentation actually it made sure that people here can understand MOSIP in a different way. Yeah, thanks for that. I would like to understand, you were the first, actually nearly the first implementers of MOSIP, and you studied MOSIP long back, starting from 2019 or 2020, I believe.
Yes, exactly. Yes.
I would love to understand, how much time, learning curve that took place for you for the first implementation, and now obviously you are going for the second implementation of MOSIP. Yeah.
Okay, so to answer this question, okay, so I will put it in two parts. First part is onboarding the journey with you, as I said, in 2019. So in 2019, there was so many versions of MOSIP. So at this time, the requirements are changing, and you are putting more and more, let's say, functionalities and features. So the learning curve it's always going, like since 2019, and it's going and going and going. So because every time there's a new version, we put it, we explore it, we integrate it. Let's say also we put our integrated, because we were in a plain project. So we were inside the project, and we have the customer requirements, and we have deadlines, and also we have new versions from MOSIP. So we need to put all these things together and have crucial deadlines with the customer. We did it. We put this to work, and there was some major changes in MOSIP. We worked all this together, until we reached a really good state. So the learning curve did not stop. This is the first part. So after putting the first project and going to the next project, of course, it's totally different story, because you have this, let's say, experience from the customer also that we worked with, experience on technical choices, because this is really important. Which HSM I would work with? Which is better than the other? What is the quality of biometrics that I need to use? Okay, so many questions, like really so many questions that usually took us a week or two to discuss internally, but now we have the answers. So the learning curve is, it's totally, it's different. It's totally different project. So we succeeded in the first one with the challenges, the second one also, but we were able to, let's say, give the customer the best experience, because he doesn't have to go through all this. He doesn't even need to think about, because we already did this exercise. And we have put, let's say, norms and recommendation. Of course, we don't tell the customer, you need to do this, or you need to work with this. No. Here's our recommendation. Here's our learning lessons. We put it on your table. You can choose. So with MOSIP also is really amazing, because once you learn to use it more and more, like, you will be familiar with it. So it's like the Tetris I put. At the end, if you really know what you are doing, and you can do it very fast and very accurate. So you will have this, I don't know if any one of you play Tetris or not, but it's getting really, like, the speed high, very high speed. So you need to move very fast and very accurate. So this is the second one, the second project. We were like this, and I think it will be getting better with the third, because there's like lesson learned from 2 countries. When I say countries, it's a big thing. I mean, you have different level of experience coming from the customer, coming from the team, the local team that is actually trying to work with us, and also from the experience from the field, and new player comings, so many things. So we do all this, and we put our experience to make things really fast and easy, and the choices are really very, let's say, clear, because questions, lots of questions. If I just give you an example, you can ask 1,000 questions about the enrollment kit. 1,000 questions. So we can answer at least 800. So, which is, I think, quite good. So I'm really happy to be part of this journey after all, and also work with MOSIP guys is really something amazing. I'm looking forward to always working with them in the next years to come. Thanks, Ronak. Sure, please.
In the kernel, what do we have exactly? Is it only the backend which is communicated with all different model, or it's all the application, the kernel? Is it only the backend?
Okay, it's the short answer is yes, it's the backend, and it's, to put it like this, it's the core components. It's very core components of MOSIP that is the whole system is built on. So you need one service to talk to your HSM and handle keys and stuff like this, and another one to handle authentication and service access, and also you have another one to handle middleware, etc. So these are the backend system, kernel system, let's say. So it's part of MOSIP. It's not external components. So yeah, thank you everyone for being here, and thank you for your attention. And hopefully you will have your own journey with MOSIP soon. So good luck and have a nice day.